One. Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Julio Godinez, and welcome to today's DevOps.com webinar, Comprehensive API and Service Connectivity Across Kubernetes with Kong and Red Hat, brought to you by Red Hat Marketplace, partnered with Kong. We have a great webinar for you today, but before we get started, I need to go through some quick housekeeping announcements. Today's event is being recorded, so if you miss any part of the webinar, you will be able to access the recording for on-demand viewing. We will be sending out a link to access the webinar on demand, or you can visit devops.com/webinars. We want to hear from you, so please feel free to send in your questions at any time throughout the program by using the Q&A tab. We also encourage discussion using the chat tab, so let us know your thoughts or just say a quick hello. If you look in the handout section, you'll see that the slides for today's presentation have been made available for you to download, so be sure to check that out. And finally, stick around until the end because we are doing a drawing for 4 $25 Amazon gift cards, so stay tuned to see if you're a winner. And joining me today is Natalie Vinto, Senior Principal Developer Advocate at OpenShift, Christian Heidenreich, Product Manager at Kong, and Sven Walther, Principal Solutions Engineer at Kong. And with that, I'm going to put myself on mute, turn off my camera, and hand the program over to Natalie.
Thanks, Julio. Hi, everyone. My name is Natalie Vinto. As said by Julio, I'm a developer advocate here in Red Hat for OpenShift, which is the Kubernetes enterprise from Red Hat. I'm very happy to be together with my friend Christian and Sven from Kong today because we have some session and also, more important, we have a live demos to show you today. So, hi, Christian. Hi, Sven. How are you?
Very good. Thank you, Natalia. And thanks, Julio, for the great introduction. First time I hear my name in English pronounced correctly. So that's great. So hey everyone, my name is Christian Heidenreich. I am a product manager here at Kong, specifically focusing on our analytics and observability story. I have a long story with Red Hat and OpenShift as well. I actually joined Kong, like before joining Kong, I worked as a product manager at Red Hat as well. And in the same field, observability, did a lot of Prometheus and other cool stuff. And before that, CoreOS. So long history with Kubernetes, observability, OpenShift, and everything around it. And now it's headed over to Sven.
Yeah. Hello, my name is Sven. I'm a solution engineer here at Kong, meaning I'm doing all the typical technical things. I'm doing live presentations like today, but also helping our customers on testing out the software or filling out complex RFPs and such fun stuff in my daily life. I'm in the API management service connectivity space now since around about 10 years. So have done the full journey from the good old SOA times to modern stacks, which you see here today. And I also have a history with Kubernetes and OpenShift. The special twist here is I was the one creating the first Docker container of Kong, which was OpenShift out of the box ready with non-root user, arbitrary user ID, and all those things. And that was my first touch point with OpenShift and Kong.
That's great. That's great story, Sven. Thanks for sharing this story. It's a great example of how our contribution is enabled and powered by open source. And I'm glad you are a contributor for Kong for this integration inside OpenShift. Well, this is a great start, folks. And I would like to go now in some questions that we have in our flow. I would like to ask to Christian, your opinion, why are customers adopting Kubernetes? Why it is an important topic? What are you hearing from your customers?
So yeah, thank you. That's an interesting question. I think it has a lot to do with container adoption in general, right? So containers probably now has been the de facto standard how you package software today. I at least still remember times where I had to package software and it was like working perfectly fine on my laptop. I shipped it, it didn't work on the actual deployment production server. And the only thing you always said to your boss is like, I was working on my laptop. I don't know what's going on. Containers remove that problem. Now everything is at least standardized. You define what the application needs and it runs everywhere. With that adoption of the containers, Kubernetes has been now widely adopted as the de facto deployment or target platform for containers, specifically because it's doing such a well job on orchestrating these containers, right? It gives you, like, just in general, right? With containers and deployment, it's not just done, right? When you run it in production, you need more. You need to secure. You need to scale up, scale down. You optimize for resource, you optimize for cost. So there's so many things you need to do. Kubernetes is basically removing all that, and it's very helpful for so many different people. It's really an enabler, right? But Kubernetes, it's not just like the de facto platform for containers, but it also all the different tools that it gives you out of the box. I talked about cost optimization, resource optimization, but there are also others that enables new paradigms like GitOps, DevOps, right? With it's more like configuration by data instead of like an operations person writing code. Now you have YAML, and it's much easier, right? You don't have to learn a specific language anymore. So that is a huge simplification for a lot of people. But I think the third part I want to mention here, which I think is also important, is extensibility. I mean, now it's so easy to basically have vendors writing controllers, operators to extend functionality around their own software, which is great. Now you can encode or codify operational knowledge into your own software so that someone else doesn't have to take care of it. Again, like simplification, extensibility. I think those are the biggest points for me why a lot of people are actually adopting Kubernetes, besides being open source with CNCF and all this good stuff. But from a functional perspective, I think those are big things.
Yeah, Christian, I totally agree with you. I also think Kubernetes is kind of a de facto fabric. It's kind of like being a common operating system where everyone deploy the apps now on Kubernetes. So it's also a standard. Everyone is converging to Kubernetes, which is an open API, right? And it's easy to extend it, as you mentioned. So I think it's a very important point. And about it, we see a huge change happening in the application spaces. Companies are no longer buying things and changing them, but are more building their own. Kubernetes play a significant role in making that happen. The next question I have is, where are you on this journey of transformation? What do you see as some of the challenges that your customers are facing and how you can help them?
Yeah, I mean, there are obviously big trends, and Kubernetes is just one. Another big trend is, which counts into all kind of like the complexity and journey of a customer, is the whole microservice paradigm in the end. So instead of like having a monolith that can do everything, people are now creating microservices, enabling more reusability across the organization, stuff like that. And with microservices, right, you get into a complete different landscape, right? There is now much more complexity around, service to service communication, right? So connectivity gets important. Today we know if we use Uber as an example, right? So we're using Uber, we just call an API. We know that. But what we probably don't understand is what happens behind the scenes. We're not just calling one API, which is at the edge. We're probably calling many, many more APIs that are microservices behind the scenes, which are internal, which we call internal APIs, right?
Right.
And one of the predictions we have at Kong here is that, we have many APIs today. We probably don't know what is behind the scenes with internal APIs, but there's a high chance that there's an exponential growth on APIs that we will see in the next couple of years as well. Connectivity, again, gets really important. So big trend, microservices. The other big thing is multi-cloud, hybrid cloud, whatever you want to call it, right? Where OpenShift plays a big role. That's another thing that a lot of customers are now tapping into as well, because, today it's not just that you run one software somewhere in one software on one backend, like a bare metal somewhere on your premise. It's like you have software on Google, you have software on AWS, you have software somewhere else, right? And now you need to enable kind of like a layer that can actually provide that operational layer across all these different cloud vendors, and making sure everything runs smooth, everything can communicate to each other. So the biggest goal for us is obviously the end-to-end connectivity, where OpenShift plays a big role in the infrastructure side and the operational side and the management of all of this. So we want to make sure that developers don't really think about like, what do I need to do to actually secure this endpoint? What do I need to do to make sure that this one scales? Or what do I need to do X? Developers need to concentrate on logic and need to concentrate on providing great experience. And Kong provides, so that is like Kong's mission, is providing a platform that enables that end-to-end connectivity, making sure the developers do their job and don't care about everything else, because we care about that. Yeah.
That's a great point, Christian, because also I'm a developer advocate, so I really care about this topic, how we enable developers on Kubernetes and how we can avoid some of the complexity that may be available at the beginning when there is an adoption. We talked about transformation, or we're talking about adoption, but the other question I have, when customers are looking to modernization, to modernize, what are the new challenges that they're facing?
I mean, it's the complexity. I think that's probably the biggest thing, right? It's
right.
It's easy to say we're moving to cloud. That's a very easy to say sentence, but it's normally it's not that easy. So when I work with customers, even in the past, when I was a solutions consultant myself, we usually had customers that were not able to go from bare metal deployments to like fully enabled cloud with everything, right? Like big bang approach. You do it once and you're done. That's usually not possible, and that has a lot to do with costs. It has a lot to do with time. All these are factors that customers really care about. So it is important to know that there's no big bang approach. What we usually suggest is take pieces out of your monolith, let's say, and containerize that, and then go live with it. And then as you go, drive the next innovative project, take another piece, deploy it, containerize it, deploy it, and do it step by step. Right? It's an iterative approach instead of everything else. And this is also very important, and this is also why Kong specifically focuses on enabling customers to go on this journey, right? So we need to provide software to customers that can do all, right? Whatever paradigm you are in. If you're a paradigm on the monolith system, taking out parts, we need to support you on both the protecting the monolith or govern the monolith, as well as your new services, right? We need to make sure that our gateway, our flagship, basically is running everywhere as well, right? Because you could be on bare metal, but you could also be on a Kubernetes environment. Then the last paradigm I want to mention here, obviously, is then when you are inside an application and you have many different microservices that talk to each other, right? We also need to enable that. So there are lots of paradigms. We have the right software to do it. We know that customers usually go on a journey, and this is like a 5 years journey. It's not that easy. It's not switching and everything is there and you are done and you go and do the others. But software like OpenShift and Kong helps you on that journey, and make sure that the biggest concerns like security, connectivity, infrastructure, operational management, all this is solved for you, so that you concentrate on your business, making everything successful, creating new businesses and everything else.
Right. As a takeaway from this discussion, I think we have some of them important points, like developers can really focus, as you said, to the business logic, and they can use something like a platform like OpenShift and a software like Kong to help in the connection end to end, to help with their monolith deployment or microservices deployment. It's their app deployment, right? They have this deployment phase made easier thanks to this integration and the platform, and then they can focus on developing a new application and a new application in their ecosystem. I think it's really a good point. Thanks for sharing your thoughts about it. And this also helps help us going into a little introduction of what is OpenShift and how OpenShift as a platform can help us on addressing these challenges and implementing our solutions on the topic we talked about. I think we have some slides that we can use. Let me check if I can switch to some slide mode somewhere. Oh, yes. I think it was this one. Okay. I think you can see the slide now. Please let me know also in the chat if you can. If you have any question, please use the question and answer. We will reply, as Julio said, we will reply the answer in our question and answer. Just a very few slides to introduce what is OpenShift and what Red Hat thinks is the hybrid cloud and Kubernetes. So from our question and answer with Christian, we talked about a little bit of what are the challenges today and how we can help with software to address them. A platform like OpenShift and Kubernetes can really help on achieving this purpose, deploying application at these applications that today are containerized. And Kubernetes is the de facto standard for deploying containers. OpenShift is the enterprise Kubernetes by Red Hat. And what we discussed also today is that organization must manage an expansive application portfolio that can span a variety of technology from different areas. So this is really true because we can have multiple applications. If you think about multiple framework, multiple model, we can have database, we can have front end, back end, we can have a queue system, we can have a streaming system. So it's important that we can run our application portfolio and we can run in a kind of mixing or as we call it, the hybrid mode. So we can have some of the workloads, for instance, in the data center, in the bare metal, or in our data center with virtual machines, or we can have in the public cloud, or even at the edge. As we know, edge computing is having a great momentum. We can have also our workloads at the edge. So it's a mix of those places where our application can be deployed. And also, as Christian mentioned, there's an evolution from traditional monolithic application to cloud native. So, but not all the applications are cloud native, let's say, right? There are still monolith that we have to deal with. So a platform like OpenShift is a platform that helps you deploying and managing either monolithic and cloud native applications. And for sure, there's an enhanced support for all the cloud native tooling and software like SDK or API integration. Another important point is the data analytics. Data analytics, because we are in an era which is a data driven, is a event driven, no, as a programming model or architecture model, but also data driven. So we want to like to provide the intelligent to application. So we have also the way to connect those data to the application. And if you look at the slide, the hybrid approach is the one that has advantage the hybrid application because the application can be deployed into this hybrid architecture that support many type of application. We mentioned the monolithic, we mentioned the microservice space, but also function. If you think about functional programming or function as a service, can be a use case that can be used in a Kubernetes platform, right? So this helps us really increasing the overall development productivity. And OpenShift has also integration for developing tools like an in-browser IDE or framework SDK or IDE extensions. So there's an ecosystem that really help deploying our application in this hybrid model, which, if you recall, was mentioned before. Today, we are more and more in this multi-cloud, multi-cluster, so we can really deploy our application in different places and connect this application also end-to-end. This slide is the one I think really explain really good what is OpenShift. OpenShift is, as we mentioned, a Kubernetes platform, but it's a Kubernetes platform which is powered of many layers. As you see in this slide, the foundation of OpenShift is that run in any cloud. That's why we call it the hybrid cloud platform. Can run on bare metal, can run on OpenStack, for instance, can run on a virtual machine, can run on public clouds, and can run even at the edge. So the foundation is that you run it everywhere. And the other important step is the operating system. In our case, the operating system is RHEL CoreOS. So Christian comes from CoreOS, right? So it's an operating system which is optimized for container workloads, which is able also to enable over-the-air upgrade. And we use today a cluster for the demo that is supporting this methodology. But also at the operating system layer, you can use RHEL or even Windows Server for Windows container support. You have the heart of OpenShift is Kubernetes. OpenShift is a certified Kubernetes enterprise distribution. And what you have on top of this Kubernetes layer is the added value. What we think is the added value. So it's a pluggable system of integration where you can plug in your favorite services. For instance, you can plug in a login system, a monitoring system. You can plug in, if you look here, the platform service. You can plug in, for instance, other third-party vendor like we mentioned here, JFrog or GitLab. You can plug in the Red Hat application services, but also as application services, other one like Kong that we see today, we discussed today with a nice demo. But also if you go down, you can also integrate what we mentioned, the data services. So you can also enable data-driven insight. You can enable third-party software, or you can enable things like Kafka messaging, and also the developer productivity. So you can plug in integration like, to mention one, Snyk for the scanning of the dependency with the dependency analytics extension for the IDE. On top of all that, you have the multi-cloud, multi-cluster strategy. The multi-cloud, multi-cluster means that you have OpenShift can also act as a controller. This controller can create, maintain, patch, manage multiple OpenShift clusters. So you can have one single OpenShift controlling multi-cluster, and then you can have also the this is the Advanced Cluster Manager for Kubernetes. The other one is the Advanced Cluster Security for Kubernetes. So you can also do your DevSecOps strategy on a multi-cluster, multi-cloud side. And that, last but not least, there's the global registry, which is we call the enterprise registry. The enterprise container registry can scan your container, can use the OpenShift enhanced security to make sure that your workload are secure. So to complete this overall view, this is a platform where you can consume the service that you need on demand. There is a marketplace called the Operator Hub inside OpenShift where you can just click and install your favorite integration. And what we will discuss today, what enabled really the hybrid cloud model is this one, the integration with the ISV ecosystem. And today we're going to discuss about the integration with Kong. So how this integration helps with the connection in your OpenShift cluster, and how this can enable and enhance your experience into your ingress management and your networking management inside OpenShift. After this discussion introduction, I pass the word to Sven for his awesome demo, live demo. I remember that we will see in a moment. So, hey Sven, the stage is yours. I think we can't hear you.
Yeah, there was the button.
Right.
Yeah. Stage is mine. Okay. Then let me if I can share my screen. should be that screen, and you should see something now which looks like an OpenShift. Any thumbs up? Can you see my screen?
It's loading for me. Let me check. Okay, I can see it.
Awesome. So today's demo, we will have an application here on this OpenShift cluster provided to me. It's running on AWS. Natalie was so kind to create one for me so that I can just show everything in a real life environment. So I will now show you an application which is just being created. So it's in the development stage. It's a banking solution. They want to engage with their customers in a microservices stack. And right now, they are in a phase where they have designed what they want to achieve. They want to have some kind of consumers going over a user web interface, but also want to have some applications access that one. We want to have a Kong gateway in the middle for access control. And then we do have direct access to the APIs by the phones and also from the front end. This is a smoking gun. This is a system really being created right now. So that's all in OpenShift, but it's not done. Yeah, we are right now in the middle of the building stage. The developers are doing hard work on coding. So far, not everything is created. So there is no backend for account view so far, but we want to see how much we already have and then want to expose that all to the outside world. So what we already have, so we are in the stage in the middle of rolling out the first version to our customers, is we already have created that API to the backend transactions so that someone can make a call and get a list of his recent transactions and create new transactions in here. And this we already have documented to our developers who are creating the applications. So we're using the Kong developer portal, which is a web application where you can create documentations for your developers and they can see what APIs which are available and how they work. And you can see them here, like here, the transactions API on the system. And then you can do things like you might know, trying things out. Let's see, I want to see all transactions I have done recently, trying them out, getting response here and working with them in a live environment. And this, of course, you can do here on our developer portal, but you can also use any client of your choice. It could be as easy as a curl script. It could be the iPhone application. It could be something like Postman or Insomnia. So Insomnia is a tool like that one here, where we also have that specification imported, and we can just try things out and just say, I want to make that call list of transactions. I send it in, I get a response. I'm getting some headers. Okay, that's what we have. So it's, in fact, we are trying things out, and we can here already see a first glimpse of Kong. Yeah, there is somehow a Kong in between. So Kong tells me that it's in between, how long the upstream took to get the answer out. And there's already something happening here for us, as we can see in our picture. Yeah, we make an API call. Kong is in there. Kong is handling the call, and it's forwarding it here to our backend system. That is what you would know in the OpenShift world as an ingress. So we have an ingress here available for the API. And now we want to do something more with that than just saying, yes, we're going through. So that's the idea of an API gateway, of an ingress controller. We want to make some kind of policies in place. So the first thing we want to do is we want to make sure that nobody tries with a brute force attack to get to the backend system. So we want to secure it using a rate limiting. So we just say you are not allowed to make here calls in tens of thousands per second. So we go ahead to our OpenShift, which is over here. And we can see we do have here different pods running in our bank application. We have the transactions backend. That's where we see our API. And we do have already front end running. So those are the two components already existing in our infrastructure. And now we want to secure this backend that it's not fully open to the outside world. So we go to our OpenShift. And for those of you not knowing about OpenShift command line tool, there's an OpenShift command line tool called OC, where you can remote control your OpenShift. And we now want to do something like securing our system. So we say we want to have a look on the gateway side, and we want to apply a rate limit. To do so, we can apply this ingress resource, which tells us, we want to expose the API, but we want to expose it using a plugin which is called rate limiting. And here are some settings. For example, that we say there's a 3 calls per minute setting. How do you get it applied? Well, it's as easy as saying OC apply -f, and whatever you want to apply. So we want to start with rate limiting. Applying this. This is then catched up by the Kong gateway. The Kong gateway applies that configuration, which you, by the way, can also see here in our user interface. So we are also visualizing everything you configure. So there's a management user interface where you can see all the services and routes. And we can see here, for example, that we have here this API up and running. And if we look at here, we can also see there's now a rate limiting plugin attached to it. And we can also see already some statistics on the calls we just did and tried the first things out. So let's get back to our client, make a call again against this API and getting some response. And we see, okay, there's something happening more in here. And we obviously see there's a rate limit now of 3 calls happening per minute. 3 per minute, and then we have 100 per hour. So if we make enough calls here and a quick enough time, we are getting a rate limit exceeded. So we see here preview rate limit exceeded. So we have now already secured that API by just applying a plugin or policy, or whatever you want to call it, in here. So our transaction API is now a little bit more secure. We can do much more, and we will look at that right now, how we do more things than just rate limiting. But an API is one thing. We also have already created in our environment here the front end. It's already deployed. We have just seen it in OpenShift. It's a running container. So let's open that now here in our browser, and let's have a look at the front end. And we will notice, oh, we do not see a front end. There's nothing exposed. So we have it already deployed in our backends, but it's not available to the outside world. So what we need to create, once again, an ingress telling Kong that it's there and that should be exposed. So we go back to our system and say we want to apply an ingress where we want for the front end an ingress to be defined. Once again, telling Kong that it should now forward that to that backend system. So we are reloading in here, and we are getting, in fact, a front-end system to our system. So we can see here also the transactions. That's a live system looking at the calls, and I can now here do my orders, my profile, and so on, getting some information about the API. So it's a web front end for this bank to get access to everything in there. But once again, we have here an issue. This one is way too open. Right now, this one, I have not authenticated any kind. I'm seeing all transactions, which is not great. I want to make sure that the right guy is making the calls here. So let's have a look at our drawing, what we want to achieve. We had the idea that Kong should somehow make a token-based authentication, that we want to have some kind of JOT being in place so that not everybody's allowing to get access to frontend, but he has to authenticate first. Once again, we just apply an ingress with some different settings, which we already have here in place, where we say we want to apply some OpenID Connect. So we apply that one. Also apply -f ingress OpenID Connect. Kong fetches up that configuration, changes the ingress of our web front end. So we go to our web front end, say we want to go to the home page and reload in here. And suddenly we are not allowed to make a call anymore. So we have now been redirected to a single sign-on solution for authentication. As you might see, this is here a key cloak as an example. It could be anything. It could be Active Directory. It could be Auth0, Ping, whatever. And here our banking customers are already registered. So they have their account with the bank. So they can log in and say, I want to log into my account with the right password. Here we go. And as we are bank, we also have enabled multi-factor authentication, that we're really sure that nobody makes something wrong. And I do have here a hardware token, which I need to physically touch now on my machine. Have touched it. And now I'm once again sent to my front end, and I can do my work now here as being an authenticated customer of that bank. That is the first part of what we have to show today. This is the idea of an ingress, and a gateway as a gatekeeper between the outside world and the inside world, which here takes care that who's making the call, what is he allowed to do. That's the way from the outside world into our OpenShift cluster, which runs down here. As you see, that's our OpenShift. And now we want to do something more. We are here in the world of microservices, and we can see that Kong is making calls in behalf of the phone directly transactions, but also it's making calls to frontend, and frontend in itself makes calls to transactions. So how can we see that? So how is that even possible that we can see more than just this at the edge? And this is because we have already created here a so-called service mesh. A service mesh is a security pattern where we can secure all transactions within a running OpenShift. So it's not only about the edge, it's really within a running OpenShift. And I have that running in here, so I can just have a look here at the running service mesh on my cluster, where I can see what is installed in that cluster, what is part of that cluster. And I can see I have already a mesh in place. And what have we already configured? We are already automatically logging things. We are already creating statistics and metrics in here. We also have put in here MTLS. So this mesh already has done in the background while we have been clicking. You have not notices at any kind, and the developer does not even need to know. Every communication in our application, all those arrows, they are MTLS enabled. So everything here is secured by certificates automatically. The developer does not need to know, but everything is secured here. So now we have here a mesh. We also have something like a Zipkin Jäger in here. So we can have a look at, okay, what is the traffic? How is this ongoing in our mesh? And we now have the full trace, not only the incoming from the ingress, but the full trace on how's traffic progressing. So if I open up here a view on that Jägers in here and have a look here, how is the system architecture? I can see live traces on what is ongoing from where to where. So I can see the gateway is making calls to the front end, and it's making calls to the back end directly. And they can see here, okay, we also have some calls. The majority have been from Kong to our front end, which then made call to our back end. But we also have this direct calls where the application, the iPhone application directly makes calls. So we now have suddenly an insight on actual traffic flow within our network from hop to hop to hop, from microservice to microservice to database, which we can then monitor on all stages. How is this possible? Every container running here in our OpenShift automatically gets a so-called sidecar, also known as data plane. So if we go back to our OpenShift and look at, for example, our front end, we will notice we have here our front ends running. That's the Bangkok front end running right now. But automatically, and that's an automatism the developer does not even need to think about, he also gets a so-called data plane or sidecar attached, and that one makes all the logging, tracing, the MTLS encryption. That happens automatically for me. So this one is deployed automatically. I deploy a new container. It gets automatically deployed here in the mesh, so that it's then part of the mesh, which we then can see here on the overview. We can see, in fact, all services which are available. You see the backend, the front end, the Kong itself, and there's another placeholder running somewhere else in my mesh already. And we can see all the scaled out. So Kong, the gateway, is scaled out to 3 instances, or the placeholder is scaled out to 3 instances. So that's a full view on my mesh. But right now, we are only seeing things. Now let's do something about security. And I have done something which you should never do in a real world. I have allowed everything to everything. So my mesh is a full everything is allowed. So there's some kind of traffic permissions, which is called allow all, which means in my mesh so far, Kong is allowed to make call to front end is allowed to make to backend is allowed to make to other backend, database. So everything is allowed, which is not what we want. We want to have zero trust. We want to make sure not everybody's allowed to call everything else. So what we do, we will now remove this not real nice policy, which I do have here in my traffic permissions. Let's see, allow all, and I just say OC apply -F, and allow all should be gone. I do not want that everything is allowed to talk to everything in my mesh. So I'm going back to my front end, trying to access it now. And suddenly I'm not allowed to make calls here anymore. So everything is blocked. I'm not allowed to make the calls here anymore. Oh, I did it. I'm talking and I'm wondering why I'm talking the wrong thing. I have to obviously say delete. I just applied it again. So now real world live demo. Okay, something is breaking down. Now it's broken. I like breaking things. So what has happened now? even the connection between the gateway and the frontend is now denied. Everything is denied, nothing is allowed anymore. So we want now to make that more fine-tuned and allow everything. So what we can do, we can say we have here some policies where we allow, let's say we want to allow front end. No, we want to allow Kong to the front end. Yeah, what it tells us from the Kong service to the front end, we want to allow that one. So we say OC apply, this time it's apply, not delete. I want to allow Kong to front end. And if we have done so, going back to our not running system, reloading it, we are now once again allowed to make a call from Kong to front end. Still, we do not have permissions to go from the front end to the back end, which you will notice if you go here to our transactions, which is now suddenly not allowed. So I'm not allowed to make a call from front end to my transactions backend, which is the next policy. Yeah, it's the same concept. I just say OC apply -f, and I want to allow from front end to my transactions endpoint. Saying please apply that policy in here too, which by the way, you can always also look here in our user interface where you can just see traffic permissions. We now already have 2 of them in place where we are allowing front end to transactions, and now we allow also Kong to front end. So if I reload now that one here again, suddenly that connection also works in here. So we have now suddenly the ability to really make fine granular decisions. What is allowed in my OpenShift to call what other service is my OpenShift, which is a zero trust network that you say, even if an attacker somehow got access to one of my services, he still is not allowed to make a call to other backend services. So the last thing, and then we will get to the Q&A section, is right now, this is a quite binary decision. Right now, this decision is roughly about, okay, we want to allow yes and no for this physical network connection. Yeah, and they can also enable here the physical connection for that I say I want to allow from Kong to the transaction backend. So if we have everything like before, so everything is allowed now. But maybe I want to make it more depending on the call. On the call, we are already authenticated using Kong. Kong already has created a token. You remember we have logged in, so we have already a token in place. So we can also in the mesh apply a policy where we can look into the token. This is done using a protocol or a technique called OPA. Open Policy Agent, very important security pattern in a modern CNCF stack, is a language, a way to pass the request. So let's say I'm now going in here saying, call is incoming, and I'm approving it if the JSON is verified and all those things in here, and only if that role is part of that token. So we can go ahead now and also say OC apply -f this OPA policy, and we now have an open policy in there. And the token I have already here available on my front end is only allowed for front end. So if I go back to transactions, once again, I'm not allowed. So my token is just not me as a user being identified. I'm allowed to the front end, but with that token, I'm not allowed to make a call to the transactions from the front end side. And that is then the last bit of security. It's not only about connections on a layer 4 level. It's really about looking into the tokens, looking into the calls, and so on. So that's the overview on what you can achieve with both the gateway as the ingress, security, logging, monitoring, and then within your OpenShift in a mesh, security, logging, monitoring, tracing we have just seen for every hop within your mesh automatically. And that's why I want to finish for today, and let's see if you have some questions on our chat.
Wow, Sven, before we go into the question, let me say this is an impressive demo, of course, and also it's a live demo. So kudos to you for doing this live. I see some important takeaways, and I think we can all agree on that. So the idea is really to reduce the complexity. I think we've seen a very cool way to reduce complexity. In this case, we have an OpenShift cluster, which is it's called ROSA, Red Hat OpenShift on AWS, which is a managed cluster. So some SRE team is managing that. And then on top, we install the Kong operator. We install Kong as an integration. And with Kong, we were enabled to add to our Microsoft-based architecture with multiple programming language deployed as a container. We were able to connect through an API gateway. We had the mesh level. We were reducing again the complexity. So developer doesn't need to struggle with networking, ticket opening, or other kind of stuff. It was all web-based, let's say, empowering developers to connect things. So I'm really impressed about this demo, and I think we touched the point, Christian, what we were discussing before about reducing the complexity.
Yes, I think especially because Sven has shown us how easy it is to set everything up, specifically configuration, right? By a click on a button, you have rate limiting. Click on a button, you had security. Click on a button, advanced security inside your mesh. You know, that really shows the power of the Connect platform and what Kong is providing for specific paradigms, right? As well. You had connectivity at the edge with the API gateway. You had connectivity within an application with Kong Mesh, right? So you know, we really help everywhere. So I'm really excited about this. Great demo, Sven. First time I have seen this demo, at least for me. I haven't been here so long, so it was great. It was really cool.
I tell you a secret. It's the first time it ever has been presented, because I'm not making that up. That application is right now being created live. So that I'm limited to front end and transactions is because I only have that one finished so far.
Nice. That's even more impressive. So everyone, you here on this call, you have been live for the first time seeing that demo. So that's really impressive.
Christian, to what you said at the beginning about the extensibility, also what we saw from Sven, which was applying some YAML file, some configuration. Those are custom resources that came from the extendability. You know very well, it's the operator's pattern. So there's a Kubernetes operator installing the software, providing additional API on top of Kubernetes, extending Kubernetes the Kubernetes way, so we can control the software in this way. Like we deploy an application, we control the network rules, like Sven showed.
Yeah, I think like specifically to operators, I've been obviously very familiar with that concept since it has been coined by CoreOS mostly. You know, operators are pretty great, like, you know, codifying operational knowledge by a vendor, right? So if you ship something very complex, like a database as an example, right? You ship software like that. Usually, you know, you ship, you sell, and then someone is actually taking care of the whole operational aspect of that software. And it's pretty hard, right? You need special training to do it. Operators actually enable you to not care about that because someone already cared about it, codified it, and shipped it to you. So you just, you know, go deploy, and it's just running, right? Obviously, it always depends on the vendor how much it is codified. But the promise really here is to make sure that the biggest concerns are already solved within the operator. So it's a great pattern.
Right. And I think we have some question in the question and answer. There's one question asking, has Kong community all this feature of Kong Enterprise?
Obviously not. Otherwise, we could not sell anything. Yeah. So community is the gateway, is the ingress controller. But I already have shown you some plugins which are enterprise only. For example, this OpenID Connect plugin, which I've used to make this authentication with multi-factor and the key cloak. That's a typical enterprise plugin. So you can choose to build with open source, but then you get a set of specific plugins. With enterprise, you simply get more plugins. You also saw this developer portal in the very beginning. We had the documentation. That's an enterprise feature. So the enterprise offering is more than the gateway with some more plugins. It's more about the user interface, the developer portal, and more. But the concept is the same. It's just more functionality in the enterprise version.
Yeah, I think we have additional question from. I think the other question we have: what are the key challenges customers are facing in this new cloud era?
Most of them I already mentioned. Complexity. So it is really about where the journey that customers are usually going through, coming from a more legacy type system to this new cloud area where you have hybrid cloud, you have microservices, you have different protocols. There's a lot of choice and a lot of complexity, a lot of technologies. You need a partner in crime to help you on that complete journey, right? So with our great partnership with Red Hat, obviously, you have a great combination of infrastructure concerns that Red Hat is perfectly suited, hybrid cloud, and you have the connectivity concerns where Kong is, perfectly a perfect fit, right? So partners, and you said this before, Natalia, right? A journey like this, complex environments, everything, you can't do it without partners. And I'm always happy to see that great collaboration like Red Hat and Kong brings such good quality, features and capabilities to customers who are struggling with something like that, right?
Right. Yeah, I think the power is really this ecosystem of partner ISV, third-party vendors that can add their software as an operator in the marketplace, which is the operator app, and then the vendor can support this for the customer, OpenShift customers. So if you want to use Kong, you install Kong in the OpenShift, and then you get the support from Kong when you use Kong the enterprise. So it's really cool model. And I like it because it gives, again, the kind of a plug and play. You can plug the thing that you need in your cluster and make your journey. We mentioned, Christian, monolith microservice, but we're assuming everything is stateless. It's not, as you mentioned. Operators brings also the stateful approach, right? Makes also the capability to control a little bit more complex thing. So I think it's really important to be aware of this heterogeneous environment scenario. And we have instrument, in my opinion, to deal with those challenges and implement a very good solution. Like Sven showed today, I really like also the framework heterogeneity. Like there was a Python, there was a front end with Node.js, there was I think Java. So
WebAssembly, .NET. Yeah, we are fully open. OpenShift is fully open, and we are fully open on where to run.
That's great to hear. That's great to hear that we have an open ecosystem. So it's really cool. I think another note was about the security. We touched. I liked your kick-lock integrations, Ben. What do you think to build such modern application with this architecture? How this integration can help in the security part?
Well, everybody who has ever tried to understand himself how OpenID Connect and token exchange and all those things work and do it in a manual way, like I did maybe 5 or 6 years ago when there were no libraries, you get a headache. It's complicated, and everything in security you do on your own, you make some mistakes. So it's always a good idea to have that in a product which is proven, which is something where security specialists have built that out so that we can be sure that token is not only passed, it's also the signature is validated in the right way, that we can enforce authorization based on roles and groups and so on. So trying to reinvent the wheel of putting security in each and every microservice is a pattern which is not scaling at all in a microservices stack. You need to have that in a central point where you can be sure there's actual code which works and not a library which someone has copied over from microservice A to B to C, which then has an error, and then we have to patch all of them. Yeah, think about Log4j. Yeah, that's the topic we all hearing all the day right now. And that's the library everybody has used in each and every microservice. And now you have to find each and every microservice and patch that microservices for that logging framework. With the gateway, you have one central point. By the way, we are not Java-based, so we are not at all affected by that one. So we are on Nginx based instead. So that means you have a central point of fetching it, also central points of governance. We can see those attackers now in the central point and seeing who's trying to make calls, and you can see, is there some spike? Yeah, you can say, okay, you make the rate limiting to make sure that brute force is not happening, or make specific filters and say we are not allowing specific calls because they can contain this malicious code. That is something where the idea of a gateway is coming from. Yeah, that's where the ingress, the gateway idea is coming from, and this is now being extended into the full infrastructure, the mesh idea, because somehow an attacker can get access to one. Let's say he uses Log4Shell and has one of the many backends suddenly taken over. With that, with the mesh in place, he still has no ability to jump to the other hosts if there's no traffic permission for him. So he's there, has his one microservice which he has taken over, but he's still locked in to that one single service, which is bad enough, but it's not taking over your whole infrastructure.
Yeah, I think I just want to add one point. When we talk about the digital transformation, right? Like customers going from legacy to this new cloud era. We talked about technology quite a lot, but I really believe that technology is just one pillar. You can't solve everything just with technology. That's not possible. So we see a lot of customers applying different principles based on, I think, the three most important pillars. The first one, as I said, technology helps a lot, doesn't solve everything. You need the right processes in place as well. That helps with standardizing, that helps with service discovery, service reusability, like everything. And the third thing, which I think is also really important, is the people. Right? You need to make sure that the people understand those new concepts and are on board with everything that you want to apply. Without those three, like focusing on those three is probably the most important part. Just don't only focus on the technology, focus on the other things as well.
Yeah,
and then
make it for the people, the developers. Yeah. I was a backend developer in an earlier time. I'm doing it right now for this front-end application. And no developer can be an expert in everything. Yeah, he might be the best expert in how to make good database calls, but he needs to know how certificates work or how JOT works. Yeah, that's something he's not special. He doesn't need to learn that. He does not have to ask for. Just says, I'm applying this policy, and then I'm secure because that's a central thing set up already for me in my mesh.
Cool, that's cool. And I like what you said also, Sven, about having a single point of control. So you can, for instance, use the hybrid cloud console controlling multiple OpenShift cluster. Then you can use the console to control your API, your ingress. It's very powerful. This is giving really power to developers that can control everything, and also to the ops people that can control the multiple cluster and in a multi-cluster, multi-cloud way. I think, folks, we're at the end of our session. I think we have to pass over to Julio, which is going to remind us, do some final reminder for this session.
Absolutely. Thank you, Natalie. Just a reminder that today's event has been recorded, so if you missed any or all of the webinar, you will be able to watch it again. We will be sending an email with the link to access the webinar on demand, and you can also find it on devops.com. Just look in the on-demand section in the webinars page, and you will find it there. I did mention at the beginning that we were doing a drawing for some Amazon gift cards, so I'll read those now. Our first winner is Manuel R. Congratulations. Our second winner is Jeremy H. Congratulations, Jeremy. Our third winner is Musa C. And our final winner is Maz M. So congratulations to our winners. We'll be reaching out via email with instructions for claiming your Amazon gift card. So please check your inbox. And if you don't see it there, check your spam folder. Gentlemen, thank you very much for taking the time out of your day to put this presentation together and for giving us an hour. It was really interesting. The demo was great, so I'm sure we all appreciate it.
Thank you. It was a pleasure to be here with you today, Julio, Christian, Sven, and I hope to do another session all together. It's super, super cool. Thank you.
Excellent. And public chat, also really enjoyed it, so it's great to see that. I'd also like to thank the audience for their time and engagement, as well as Red Hat Marketplace for sponsoring the event. This is Julio Godinez signing off until next time. Take care, everyone.
Thanks,
Bye.
everyone.
Bye.